Assalamu alaikum students. Currently we are studying chapter number 9, chemical equilibrium. Today our topic is law of mass action and its derivation. Generally chemists express the composition of equilibrium mixture in terms of numerical values. These values are the rate of reactants and products at equilibrium. These values can be determined by a relationship known as the law of mass action. Two chemists C.M. Goldberg and P. Wage proposed the law of mass action. By moving towards its statement, it states that the rate at which a substance reacts is directly proportional to the active mass, and the rate at which the reaction proceeds is directly proportional to the product of the active masses of the reactant. The term active mass represents the concentration of reactant and product, and it can be expressed in terms of square brackets. Consider the following derivation. In this derivation, we will find the equilibrium constant, which is the ratio of the product of concentration of products to the product of concentration of reactants, each raised to the power equal to the coefficient in the balanced chemical equation. बैलेंस केमिकल इक्वेशन में जो आपके पास कोफिशेंट या न्यूमरल्स गिवन होते हैं, फॉर एग्जांपल 2H2O, वो जो 2 होगा वो स्क्वायर ब्रैकेट के ऊपर पावर की फॉर्म में आ जाएगा, रेज टू द पावर. And then moving toward example 9.2, writing equilibrium constant expression, we have to write the products at above equal to, and then the product of reactants in below the products. Then self-assessment exercise 9.2, I will attach the solution of this exercise too. By moving toward the conditions for equilibrium, there are three conditions of equilibrium: that concentration of none of the reactant or product is changed, temperature of the system is kept constant, pressure or volume of the system is kept constant. Then ways to recognize equilibrium. Equilibrium state of the chemical reaction can be determined by determining concentration of reactant and products. When constant concentration of products and reactant is observed, the reaction is at equilibrium. This can be done by both physical method as well as chemical methods such as titration and spectroscopy. Then I will tell you earlier about the units of equilibrium constant. Equilibrium constant may or may not have units. In the equilibrium constant, each figure is represent within a square bracket represent the concentration in mole decimeter minus Q. The unit of equilibrium constant therefore depend on the form of equilibrium expression. Here are following examples that how we will give a unit to the equilibrium constant expression. There is self-assessment exercise 9.3. I will attach the solution of this exercise too. Then there are some related questions in the exercise. I will attach the solution of these questions too. Students, you have to complete all the related work on your notebooks. Thank you.